When performing battery installation or battery maintenance, one of the most important measurements is that of the intercell connection resistance, which ensures a low resistance conduction path. Intercell connection resistance measurements are made with a microohmmeter. The test probes are put in the center of the posts, and the microohmmeter measurement is taken with the instrument. We can see here the connection resistance is approximately 19 microohms. When making measurements on this battery, it has one terminal or one post per cell. So you're going to first make a measurement of the contact resistance at the positive post. And you do that by placing one lead on the connector barrel and the other on the post. When that's done, you can move to the first intercell connector. And because there's one post per polarity, one measurement is necessary. You want to get the intercell connection measuring devices in the middle of the post as close as you can, avoiding contact with the intercell connector. You then move to the next set of intercell connectors once that reading is measured. And again, you want to be as close as possible to the center of the post. This battery has two posts per polarity. So you'll make two intercell connection resistance measurements, one from the leftmost post of one cell to the leftmost of the second cell. And you make that measurement, and then you make one from the rightmost post of one cell to the rightmost post of the next cell. The reason you do this is both of those resistances are equal so that you only need to compute one baseline measurement. This battery is a valve-regulated battery with button-type posts. When you have a button-type post, you need to get behind the intercell connector on the button post itself in order to correctly measure intercell connection resistance, because you want to measure the contact resistance at the point of connection of the intercell connector to the button post. This is a close-up of the button post, and it shows the interface of the intercell connector with the button post. When placing the lead from the microohmmeter, you want to get the test lead on the button post itself, and you can get in where we're pointing right now, and that will measure the contact resistance of the intercell connector. We're next going to demonstrate how to place the leads on these connections. When placing the lead from the microohmmeter, we want to get in on the button post so that we can measure the contact resistance of the intercell connector. This shows the placement of both test leads from the microohmmeter, one at the negative and one at the positive, to measure the intercell connection resistance of an intercell connector connected to cells that have button posts. So we ensure that we get the contact resistance included in the measurement. When making intercell connection resistance measurements on cells that have button-type posts, you do not want to make the mistake of putting the test probes on the hardware itself, that is, on the bolt head, because the bolt head is a very high resistance connection. In addition, you will not be able to get the correct measurement because you don't measure the contact resistance. You're just simply measuring the resistance of the bolt heads and the intercell connectors. So that's the improper way to make that measurement. In summary, when making intercell connection resistance measurements, always wear the proper personnel protective equipment. Remember, intercell connection resistance is an important part of battery installation and maintenance, but it's often omitted by the users. Remember to put the test leads directly on the post, getting as close to the center of the post as possible. Do not let the test leads contact the intercell connectors directly, and do not place the test leads on the connection hardware. Remember that when measuring intercell connection resistance, the number of measurements made on an intercell connection is equal to the number of posts per polarity, or poles per polarity, of the cell or the battery being measured. So if there were 2 posts per polarity on a cell, you would make 2 measurements. 3 posts, 3 measurements. 4 posts, 4 measurements. And of course, a single post is 1 single measurement. When you select where to make the measurements, those measurements should be as equal as possible so that you only compute 1 baseline resistance. For example, if we had a post or a cell with 3 posts per polarity, we would measure the leftmost post on one cell to the leftmost on the adjacent cell, the middle post to the middle post, and the right post to the right post.